So for this final video for the year, this one is for the spring exam review. Um, let's look at what we've done this spring and go over how to do some of these problems. So for the first one, we want to know what the amplitude of this trig function is. Well, if you remember back for those functions, we had y equals a times, and it could be either sine or cosine. So I'm going to say sine or cosine, either one works, of, and then we had bx plus c and then plus d. Well, this a was the amplitude, this b affected the period, this c, you could say affected or was affected by the phase shift, and then this d was the involved with vertical shift. Well, a and d, this is the amplitude and this is the vertical shift. So for the amplitude for this one, it's just that number right in front, which is just 3. The period was slightly more difficult than that. Well, if you look back through your notes or anything, we'll see that b was equal to 2 pi divided by the period. Or, the other way we looked at that formula, the period was equal to 2 pi divided by b. So in this case, if we look for a b is the number with the x that's right inside the parentheses. So we end up with b, this is going to be 2 pi divided by a third. And when you divide by a fraction, you keep the numerator, you change it to multiply, and that becomes 3 over 1, or just 3, which is 2 pi times 3, which is 6 pi. So number 2 is 6 pi. For number 3, to find the correct equation of the graph, we need to decide whether we want to use sine or cosine. Well, it's already starting right here. And cosine starts at the highest point. So if we go with cosine, we have no phase shift at all. So the amplitude, we'll look at how tall it goes from the middle. We'll find the middle of the graph. There, the middle tells you what our d is, what our vertical shift is. And this one has no vertical shift, so we automatically know d is 0. And since there's no phase shift, because it starts right at the highest point, for cosine, there's no phase shift, so there's no c. Now the period goes from the highest point all the way back to the highest point again, which is about right there. My pen doesn't like to draw straight lines, or at least not straight up and down. So that went from 0 to pi. So the period is equal to pi. And we already said just a second ago that b is 2 pi divided by the period. So for this one, b is going to be 2 pi divided by pi, which would just be 2. And a is the amplitude, which this graph you can see from the middle to the highest point. How far up did it go? It went from 0 up to 3, so a is 3. So a is 3, b is 2, c is 0, and d is 0. So this one, the easiest function would be y equals 3 times the cosine of 2x and plus 0, no parentheses, you can say this right here, parentheses there, plus or minus 0, and then plus or minus 0 at the end. So that's the easiest answer. Now, there are some other answers that are acceptable. You could have moved over, we'd have a phase shift to here, and then it'd be a negative sine graph. We could have moved here and had a negative cosine graph. Or we could have moved it here and made this the starting point for where we're going to start drawing it, and then it has a phase shift, but it's a positive sine graph. All those answers will be in the key on Canvas, but I'm not going to write those all down now because they're the easiest way answer is the best, I think, or the best answer is the easiest one to find. Now for this one, I notice the middle of the graph looks like it's right about there. Now, if you want to make sure it's the middle, look at how high it went. It went from 5 up to 8, so it went up 3. Well, it should do the same thing. If we went 5 down to 2, that went down 3, so we are at the middle. So that tells me my vertical shift, my d, is 5. And we already said the amplitude went up 3, and down 3, so the a is 3. Well, the period went from when did this start until when is it back to starting all over again? Well, you notice, well, that was, I think, well, I might be slightly off a mark on that, but looks like it is about 3 pi. So if we let the period be 3 pi, then b is going to be 2 pi divided by the period, 2 pi divided by 3 pi, which is 2/3. And the c, well, if we're starting here, our c, there's no phase shift at all, so c is 0. So the easiest one to come up with on this one, I'd say, is y equals, or f of x equals, if you want to use function notation, same thing, 3, and the graph that starts in the middle is sine, so 3 times the sine of bx, so 2/3 x, minus 0, so I close my parentheses, I don't have to put a minus 0, plus my d, plus 5. That's the easiest one. There are some others, but they're way much harder to figure out, so that would be the best answer for number 4. So for number 5, we're going to use some of our, we're going to the trig identities here. Well, if you remember when we did this in the 5th, 6th weeks, we said if you can rewrite these in terms of sine and cosine, they almost get a lot easier. So cotangent, and this is the formula chart you would get on the test, cotangent is either 1 over tangent or cosine over sine. Let's use cosine over sine. Cotangent is cosine over sine. That's just the numerator. And cosecant is 1 over sine. So if I said take a fraction, divide it by another fraction, well, what you end up doing is taking the numerator, which was cosine over sine, leaving it alone, changing the divide to multiply, and flipping the second one, multiplying by the reciprocal, which would be sine of x over 1. And then I see I have, when you're multiplying, if you have a common factor on top and bottom, you can divide it out. And we end up with just cosine of x over 1, which is just cosine of x. For number 6, the first one's already in terms of cosine. So I'm just going to leave that as cosine squared. Well, secant squared, secant is 1 over cosine. So secant squared would be 1 over cosine squared. So this is 1 over cosine squared. And if we take a number times its reciprocal, this is all you can put over any number over 1. If we take a number times its reciprocal, 1 in the numerator, 1 in the denominator, everything cancels out. We're left with just a 1. And that's number 6. For number 7, we have a girl that's flying a kite. So let's see. Can I draw? We got this person down here. Let's make her into a dress so you can tell it's a girl. There. It's a girl flying a kite. So out the string, she has a pink kite, but I don't know if I can get to pink. So how about purple? Is that close enough to pink for now? So this is her pink kite. And you got its little tail. You know, kites have the little things hanging down. So find her little kite right there. And well, now I need to get back to my blue pen. So let me do this real fast. Can I get to it from there? Oh, I didn't go far enough down. Okay. So we got this girl flying the pink kite. Well, that makes an angle of elevation of 30 degrees. So we make a right triangle because height, and we're looking for how high above the ground. So we're looking for how tall this is. And height is always perpendicular, so that's a right angle. We know that that's 30, and we know there's 120 feet of string. Well, this is the string right here, 120 feet of string going to the kite. So somehow we need to come up with an equation to find the height. And it looks like I have this angle, and it looks like I'm looking for the opposite, and I know the hypotenuse across from the right angle. So if you can remember back to sine, cosine, and tangent, we had SOHCAHTOA, the one that deals with opposite of the side, opposite leg that you're dealing with, and the hypotenuse, O and H, is sine. So we say sine of the angle, sine of 30, equals opposite over hypotenuse. Now to get this x by itself, to undo dividing by 120, multiply both sides by 120. And so we're going to take our handy dandy calculator, and I'm going to go home and I'm going to choose a calculator, and first thing I'm going to make sure I'm in degrees. If I wasn't, I would go back home, go to settings, choose document settings, and make sure you choose degrees, and then click OK, or make default's probably a better choice. Click OK. Now you can go to a document, and now I can type in, because the 120s are going to divide out, so my x, don't worry about the x, we're just going to type in 120 times sine of 30. 120 times trig, sine's the very first. Ooh, I didn't, my cursor moved, I wasn't paying attention. 120, let me fix that real fast. Backspace. 120 times sine of 30 is 60. Because sine of 30 is actually 1/2, so this is just x equals 60, and our units are feet, so 60 feet. For number 8, we want to find an angle between 0 and 360 that terminates in quadrant 3. Well, that means, whoops, if I draw my unit circle, a blank unit circle, we went around counterclockwise was positive. Well, this has to be where it ended in quadrant 3. So we're looking for that measurement right there. Well, a 53 reference degree angle means that's 53 right there. Well, if that's 53, and we've already, if you can tell by looking, we've already gone 180. So all we have to do is take 180 plus 53. And if you don't want to do that by hand, you can say 180 plus 53, and you get 233. So 233 degrees is the positive angle that's in the third quadrant. So that's our answer. For number 9, says use the unit circle to evaluate the following. 315 degrees. So if we pull out our unit circle on this formula chart here, 315 degrees is right there. And we're trying to find the sine of that. So sine, if you remember in these ordered pairs for the unit circle, the x deals with cosine, and the y was the sine. So sine, I guess I use theta, and that way don't look like x and y's. So sine is the second one in the ordered pair. So at 315, there's our answer. So sine of 315 is negative square root of 2 over 2. And cosine of 390, well, if you, whoops, that's not the one I wanted. If you look at your unit circle, 390 degrees is not on here. But if you think for just a little bit of reasoning here, realize, oh, if I go all the way around, how many degrees is that? Well, that's 360 degrees. 390 means I have to go a little bit farther. And if I went 360 to get to 390, I have to go 30 degrees farther. So it's the same thing as just 30 degrees. And 30 degrees is right here, and we're wanting cosine. Cosine is the first one. So it's just square root of 3 over 2. So this answer is square root of 3 over 2. So number 9, first answer was negative square root of 2 over 2. Second answer was square root of 3 over 2. It's my ugly square root symbol. And for number 10, to solve this one, I would divide both sides by 2. And I want to know where sine is equal to negative square root of 3 over 2. So if I go to my unit circle and look for square root of 3 over 2, sine is the second one. There's one there at 240 degrees. And there's also one there at 300 degrees. So our x, or our theta, is 240 degrees or 300 degrees. All you have to do is look at the unit circle and see where sine was negative square root of 3 over 2, which is right down here at 300 and right over there. Don't worry about that. That was from the other problem. Up here we had a square root of 3, but that's the x. That's not sine. That's cosine. And this one was positive, so there's no other choices. And that's as far as I can get in this video.